This is Robbie Dodenbeer, and this is my individual presentation for the CIT 260 class. To start off, let's go ahead and talk about the difference between static class variables and non-static class variables. To start off with, a static class variable is when a variable is declared with the word static in front of it, which then results in all instances of your class variables will share the same value, meaning the variable does not need to be declared each time you need it. So basically, each time you call that variable and change that variable, it will be the same across all classes. So you only need to define it once and change it in one spot, and then it will replicate itself across your program. So my example here is I've gone ahead and defined a class. I've declared the string variable with static in front of it, and I've given it a value of I'm a static variable. Outside of my class, I've basically displayed it to the console. I've called my class name dot variable name and outputs I'm a static variable. A non-static or instant class variable is a variable called with no static declaration and is declared inside a class but outside a constructor or method. An instant variable is considered a copy of a variable and can be used without impacting other variables with the same name. So in comparison to a static variable where you can define it once, and if you change that variable, it is changed across your program. The inverse is true for an instant class variable where you may define it inside your class, but you are in essence copying that variable each time it is called inside, or each time you initialize a class variable. So for instance, I've had my same class, public class something. I've defined my variable as an int and given it a value of 5. I've now initialized a new class variable in two different ones here, and I've called my x variable and giving it a different value in each one of these initialized class variables. And you can see here in my console output, it is not giving it the same value each time. It is because it's a copy, it's giving it two different values. And so I can use the same variable name across my program, but I can give it different values because I am in essence copying that variable and not referencing it like in a static variable. Moving on, next we will be talking about arrays. Arrays in its basic form is just a list of items. We have different variations of arrays. So to start off with, just a regular array is just a fixed length list of same data type values referenced by an index value. Values within that list can be changed. Arrays will always start with an index value of 0. And in this case, it's fixed, so you define your length and you are basically bound within that length limit. You can modify or update values within an array, but you can't remove values. Next is an array list. Is similar to an array, however, the difference being is that it is a variable length list of items. So you can add and remove, and they can also be of different data types. Primitive data types, for instance, of an integer, a byte, a float, these must be converted into objects first, because basically an array list is just a list of objects, or can be objects. And within that, you can change or remove those values. An array list is also implemented as a class. Finally is an enum. An enum is very similar to an array, is fixed list of the same data type, however it is referenced by a keyword instead of an index value. Values within the list cannot be changed and are considered constant. They too are implemented as a class. So as a quick example in my code, I'm going to show in my high score control, I've gone ahead and defined my array list class, and I'm calling in my player object, which is giving me my player name and score. I'm going to go ahead and define my array list using the high score object, and I'm going ahead and passing in those values. So for instance, this first line item, high score.add, this is what actually adds the object item into the array. I'm calling my high score object, and I'm passing in player name and player score. I've also provided just some more, and this top one's dynamic values, and these are just some static values just to give some context with my sort and whatnot. And down here I've gone ahead and done a sort as well, just to sort based on score. So that's a quick example of an array. Next, we're going to talk about loops. So to start off with is a for loop. And the best way to describe a for loop is when you know the number of times you need to loop through your block of code. So to explain here, in my example here, I have a for loop, and within that signature, I've defined or initialized an integer value of 0. This is going to be my counter, and the reason why we start at 0 is because arrays start at 0, so we always want to start with that first item. Next is the number of times, or the condition in which the loop can continue on. So in this case, as long as my integer value of I is less than 9, it's going to go ahead and continue to loop through. And then this increment value, each time the block of code is run, it's going to increment that value. And so it's just going to continue to loop until it reaches 9, and then it's going to stop. So next is we have a while loop. And so this is a little bit different. This is when you do not know the number of times you need the loop to go through. And so we define a condition value, and as long as that condition has not been met yet, it's going to continue to loop. So while the condition is not met, go ahead and continue to loop. So for example, I have a while, I have a variable, and this would be a Boolean value. So as long as that is not false, go ahead and continue to run this code. And as soon as that value is false, then it's going to stop the code. And then finally, we have a do while loop. So this is similar to a while loop where the loop will continue to run until a condition is met. However, the do aspect of it is you want a specific block of code or statement of code to run until that condition is met. So you want it to be run first until the system checks that condition. So you can see in my example, I've called my do loop. Here's my statements, and then while, and then it's just going to continue to run through this loop while that is false. So a quick example, I'm going to jump over to my high score menu view, and this is where I'm going to display that array of items to the user. I have my for loop right here, so I've declared a for. Here's my initialized I of a 0, so we've started at 0. And my condition is as long as we have not so it's checking the array, and calling a function of size. So it's going to know the length of the size. So 5, 6, whatever it is, it's going to continue to run until it's met that, and then we're going to increment our variable our I variable each time it runs through. Next is we're going to display on the console. So I'm going to do 0. So in this case, I've added a 1 so that we have the right value. And then we're going to display the score based on an index value. So my index value is whatever I is going to be, and that way I can loop through this and display that values. And we'll actually display this, or we'll show you this here momentarily. Next is error handling. And so instead of showing an ugly error message that means nothing to the end user, we can configure our error messages so that it's meaningful, and then we can also redirect the user when problems occur. So jumping into my code here real quick, quick example is my output. I'm going to throw within my function signature, I've appended a throws high score control exception. The reason why I've done this is this propagates the error message up to my calling hierarchy. So if I've called this function in my view class, it's going to display the error message within my view class. continuing on, it will actually first try your little snippet of code. It'll try it first. If it works, no error message will be displayed. But this catch is actually looking for an exception thrown. And so as soon as Java throws an exception, it's going to catch that, and it's going to say, hey, throw this new error message instead. And so I can either have a custom message like I have here, or I can go ahead and just say display this system message. Either way, depending on how I want to program that, this would get thrown up to the view class where this function was called. And finally, let's talk about character stream versus byte stream. Just quick history. Byte stream was what was originally released with Java. It reads 1 byte at a time, reads and writes binary streams 1 byte at a time. And the only type of language or format that use that is ASCII characters. The problem, and that was only used within Western languages. The problem with that is languages outside of Western languages use Unicode, which is 2 bytes of data, and so there was just a lack of functionality there. And so Java released character streams, which allowed for Unicode character formats, and thus you no longer had to worry about that. It would read data regardless of what format the data was stored in. And this is considered now the recommended I/O for all I/O streams. So quickly, just as an example, here is that same. Actually, I'm going to jump into the view class. And within my view class, I am. It's not my view class right here. Sorry. Within my view, I've given the option to export the file. If I call that, then it's going to call my high score report view. And here's my high score report view. Within that, I'm asking the user to provide a file path. And then it will pass that file path when it calls the save report view. So it's going to pass my array as well as the file path. So if I jump back into this one, I've received my array, I've received my file path, I've called my print writer function, and I've passed in the file path. And then it's going to use that, and it's going to output. So in this case, I've outputted a high score, player name, player score, and I've basically used another for loop to loop through each of those values and let it export into a file. So quickly, if I run my program, I give it a name. I'm going to just quickly go to school. I'm going to move locations. I'm just going to answer a couple questions. Need to remember English. Okay, so I successfully answered my question. I've been provided 35 points. Let me quickly just go to another class real quick. Okay, so now you see my current score is continuing to increase. I'm go ahead and save that. If I call, just back it out, let me call my high score menu. As you can see here, here's my high score menu. Here's me, the user. Here's just all the high scores. I can export the scores to a file, so I'm going to go ahead and do that. I'm going to paste in. I need to get my have that ready. My file here. It's always a little complicated on a Mac to know the file name, so I'm just going to paste that in. Okay. My file was successfully saved. So if I go ahead and go out to my desktop now, here's my file, and lo and behold, I've outputted my high score menu. And in just the last minute of my presentation here, I've gone ahead and shown just some basic examples of my program. I've gone through and shown the classrooms, and so my pieces to the program was I created the high score menu, I created the export, I also created the menu. So if I go to school and I click on menu, I went ahead and I'm the one that created the menu, or sorry, the map, not the menu, and I also created all the questions. So that was my involvement with the program. I'm excited to see everything go, and This is the end of my presentation. Thank you so much for your time.